This is AS Stats. We are in Unit 5 looking at the binomial distribution, and this is 5.4 expectation and variance. So just run through this quick example and then we'll see where expectation and variance really are coming from. A fair dice is thrown 3 times and the number of 6 is recorded. Then the probability distribution would be as follows. Obviously our n here is 3. Our probability of a 6 is 1/6, and the probability then of q is going to be 5/6. If you want, random variable x follows the binomial distribution for np, which is 3 and a 6. Working this out, you would have 3c0, a 6th, to the power of 0, 5/6 to the power of 3, 3c1, a 6th, 5/6 to the power of 2, 3c2, a 6th squared, this one's smaller, 5/6 to the power of 1 if you wish, and then 3c3 is a 6th cubed, 5/6 to the power of 0. As we know, summing these up gives us 1. As we know, summing these up gives us 1. So what are we going to have? That's 1 times 1 times 125 over 216. This is going to be 3. Remember these numbers here, 1, 3, 3, 1 are the NCR numbers. So we're going to have 25 over 216, timesing that by 3, give us 75 over 216. Here we're going to have, that's a 3 as well, times by the 5, so it's going to be 15 over 216, and then here we're going to have a 1 over 216. Now just stay with me here in terms of what we're doing. Here we're going to do x times p of x. There's your x, there's your p of x. 0 times this gives us 0. 1 times this, 75 over 216. 2 times this, 30 over 216. 3 times this, 3 over 216. If we add these up, 75 and 30 and 3 gives us 108 over 216. Looks a bit odd, but it's just a half. Our final row then, x squared, p of x, 0 squared is 0. It's an easy one. 1 squared, same, 75 over 216. 2 squared is 4, times the 15 is 60 over 216. 3 squared was 9, times this, so 9 over 216, that gives us 144 over 216, which is quite a handy number. Then that cancels down into 2/3. So you can see this, that expectation of x is the sum of x p x, which is going to be a half. Expectation of x is how many 6s you would expect to get with the 3. So of course it's going to be a half. You know, if I roll the dice 60 times, how many times do I expect to get a 5? I'd expect to get a 5. My expectation would be 10. So if I'm rolling it 3 times, the amount of 6s is going to be a half. That's really what we're dealing with then. And the variance, the way you work that out, is the sum of x squared p of x, take away expectation of x squared. So that's the 2/3. Take away a half squared. 2/3 take away a half squared gives us 5/12. If the random variable x is such satisfied as it is in the binomial distribution, then we can say a of x, much quicker way of working these out, is n times p, n p q. So if it follows the binomial distribution, we can work out the expectation of x and the variance of x by doing this, and we're just showing that then is the same. So up here, then I'm writing this is found by 3 times a sixth. And over here then, this is found by 3 times a sixth times 5 sixths, which is n times p times q. This then is n times p.